these slides. All right, so WAN technologies. So T1 and T3 lines are common in the United States, E1 and E3 in Europe, and this gives you 1.5 megabits per second for a T1 or 45 megs for a T3, and originally they were thick bundles of copper wire, but now they're mostly done with higher bandwidth cables. But anyway, this gives you a dedicated point-to-point connection from one point to another, like one branch office of your company to another. SONET is for really high-speed connection, going up to gigabits per second, and you can get different levels of SONET for different high speeds. Frame relay is a system designed to let many people share the same wires and get guaranteed bandwidth from one point to another, so it sorts the packets. So you can create a virtual circuit, which is as if you had a dedicated line like a T1, but at a lower cost if you want less speed. So you can have a permanent virtual circuit or a switched virtual circuit, and it addresses these circuits with data link connection identifiers in the packets. X25 was an older way of doing the same thing that was used up through the 90s. ATM is still used today. Every packet is only 53 bytes long, 5 bytes of address and 48 bytes of data, and you can transmit any kind of protocol on top of it. It's been around for a long time, but some people still like to use it. MPLS forwards WAN data using labels, so you can move multiple different protocols, many different types of traffic. And SDLC and HDLC. SDLC was another layer 2 WAN protocol, like Token Ring, and HDLC was the next version of that has these 3 modes: normal, asynchronous response, and asynchronous balanced, that just have little details of when the secondary node can speak and so on. All right, and then there are Converge protocols that let you move all different kinds of data over the same network, like storage, data storage, voice, industrial control signals, and so on. And one of them is DNP3, used by the energy sector for SCADA implementation. SCADA is supervisory control and data acquisition. These are the specialized devices to control industrial machinery, like equipment in factories and airplane control towers, nuclear power plants and such. And there are many different vendors making these things, and DNP3 is the standard used to move data, carrying all that different types of data together. So it's a multi-layered protocol, and it could be carried over TCP/IP, and it's got, as like most of these things, it had an old version that was vulnerable to simple attacks and a new version which is more secure. All right. And then there are storage protocols. On large device, on your home device, you have a hard drive or an SSD in your laptop, but on a server, you have a storage array, which is just racks full of just storage devices, and they're connected through the network to the processors. They might not even be in the same location. And so you have some kind of protocol used just to transmit that data within the data center, and Fibre Channel over Ethernet is one of the common ones, but other ones that are used are Iscsi, and these connect the data. Can you go back to IEEE? This one here? Yeah. 2012. Yep. What? There's just the there's the current standard that's more secure for DNP3 for the energy sector. All right. And so the storage protocols are used to get to load blocks of data. The FireEye talk mentioned attacks on devices connected to your box. Oh, well, the one I saw, well, yeah, okay, I think I know what he was talking about. If you get infected with ransomware, the early ransomware would just encrypt the data on your hard drive. But now what it will do is it will reach out to all the storage devices it can reach and encrypt all them too. So a network attack storage is what you might have at home if you buy a storage server, which some people do because they have a lot of MP3s or something. So you'd have a little box on your home network that is just full of hard drives and just shares that data over the network, and it would reach out to that and encrypt that too. And if you were at a company, it would reach out to your network file shares and whatever it could reach and encrypt those also. So that's the modern situation. Not all the storage is on your computer. It's on the various things you can reach, like Dropbox and OneDrive and all that jazz. And modern ransomware will try to encrypt all of that stuff. Because the idea is they want to make sure you lose all your copies of everything, so you have to pay the ransom. Anyway, so these are used for storage area networks, which are the bigger thing than network attached storage, where you have a whole network of devices storing information, and you can ask for a block of data over the network instead of from a local drive. And that's the idea. But you have a protocol used for those, and it's typically FCOE or Iscsi. Iscsi is just another way to connect networks, to connect a network to a device, which will then load data as if it was a hard drive connected directly to your system bus. That's the idea. It's just a way to move data within a data center where you have server racks moving large amounts of data around, and you have to make sort of a large-scale version of what happens inside your computer when it goes from your processor over to the hard drive. Yeah, the home network attached storage solutions, the NAS devices are what you'd buy at home. They're small and simple, where you just have one box that connects to a normal network. These SANs are a whole network just of storage devices. So if you're a company like Dropbox and you've got just incredible amounts of storage, you have whole rooms full of racks of just storage devices, and that's a storage area network. Yeah, the Iscsi, yep. Good, all right, yep, good. I see a lot of good comments there. So Fibre Channel over Ethernet is another way to do it. Fibre Channel does not have to go through fiber optics. The fiber part refers to the fact that it has many connections connecting different devices together. Fibre Channel uses special cable, but you could use Fibre Channel over Ethernet, and then you can use standard Ethernet. You can also run Fibre Channel over IP if you want to have a storage devices that are far apart connected to each other. Yeah, petabytes of storage. Yeah, that's common. You know, there's tons of storage. Big companies have a lot of it, and so you can't possibly have one hard drive or one computer. You have to have racks of storage, data centers full of storage, and then you have to access it all over a network. So here's Iscsi again. Iscsi can be routed and lets you have logical access to storage, and it uses these things called logical unit numbers to request data. Then there are virtual storage area networks. They typically use proprietary hardware and software, so you can make a virtual SAN, which will split up the traffic into groups like a virtual local area network. All right, and then there's voice over IP. This is just moving phone calls over the internet, or voice like I'm sending right now, I think uses it too. The actual audio is carried by real-time transport protocol, and the session initiation protocol is what does controls like making sure the other side is listening, ringing the phone, and picking up control signals. And there's something called secure real-time protocol that adds encryption to it. The original one does not always have encryption. And so the people have taken telephones and they pretty much all switched to VoIP phones, not because they're cheaper, but because they give you all these advanced features like press 1 for this, press 2 for that, and they're under control of the company and such. And that means your telephone traffic is traveling over the same network as your other network traffic. And so now you can attack the phones with DOS attacks and other kinds of attacks on the network. All right. Wireshark is very good at eavesdropping this. That's the first thing I did when I took a VoIP class. I immediately took Wireshark and sniffed on this stuff, and I also did that when I was doing the packet hacking challenge at the Wall of Sheep. Yeah, you can totally pick up unencrypted VoIP with Wireshark and play it back in Wireshark and listen to it. Now, if you use the encrypted protocols, it prevents that, of course. But a lot of people, at least up to maybe 5 years ago, it was very common that people would turn off the encryption to get more bandwidth, to get clearer calls. I don't know if people are using encrypted calls yet, but 5 years ago, not so much. You could totally eavesdrop on Wireshark. another issue, because phones typically are your own dedicated line that's not shared with other people. But voice over IP, your packets are right on the same wire as everybody else. So it would be a good idea to have a layer of encryption for privacy. So that's the game. You have network attacks, sniffing, and man in the middle, and everything can be done. Well, Wireshark just collects the packets from any kind of network traffic, and Wireshark is very good at decrypting it. If you do the Wireshark CTF that's coming up on Saturday, you can try some of it. Although I don't think he has voice over IP in there. And you can capture voice over IP packets and just play them back through the speaker. Yes, you would only be able to do that if you could get the packets. So for example, if they go through a wireless network and you can catch on that, or if you can connect to some port. Yes, you do have to capture the traffic. So one way to do it would be to add another device in the data center, the way the NSA did. Another way would be to reroute the packet on a network with ARP poisoning or something like that. Yes, you can listen to the conversation using Wireshark. Well, now I don't know if you can do it live. I've done it where you capture the packets and then you process them later and you can listen to both sides. You'll find two streams. Yeah. AES encrypts the packet with a key, just like anything else, so that provides security. You'll only be able to decode it if you have the key. And Wireshark is able to decrypt the packets. Wireshark cannot usually decrypt encrypted protocols. It has some limited ability to do that, but usually Wireshark only lets you see the unencrypted packets. The only cases where Wireshark can decrypt the packets is if you give it the key. And it has some limited ability to do that, but not that common, yeah. Live, I haven't seen live sniffing with Wireshark, but you can capture the packets. There is no analog part of voice over IP. Voice over IP, the only analog part is at the microphone. The vibrations of the air are turned into electrical signals at the microphone and then immediately into digital signals, and then they travel digitally through the whole network. You hear it by catching the packets in Wireshark, and then when you play it back, it plays it out your computer speaker. So it's the same as listening to my voice right now. Everything I'm saying right now is traveling over a network as digital traffic, and your end device is turning it back into audio through a speaker. So it's got an analog to digital, a digital to analog converter in your speakers or your earphone. Adam and Eve, I didn't know. I haven't heard of Adam and Eve. I don't know about that one. Yeah, your box does the conversion. Yeah, your computer, your microphone in your computer takes analog air and turns it into digital signals, which then go over the wire, and your speaker does the same in reverse. It has a D to A that makes an analog signal to speak. Yeah, it's done right at the end. All the transmission is digital. These are very good questions. All right. And so then you have software-defined networks. This is really a big thing these days. If you have virtual servers, like Amazon virtual servers, then you have firewalls and switches and routers, and those are all virtual, directing the traffic between them. And so those are called software-defined networks. You're simulating all these devices. So you have a control plane that makes routing decisions and a data plane that forwards the packets. And so this is software-defined network routing, where you configure a software device and it reshuffles the packets and arranges it. And you'll see this if you go to Azure or Amazon. There is a whole complicated interface to control the traffic among all your virtual machines. You can make virtual local area networks and adjust it. And that's what you have to do, is define the way the traffic is to move between all those virtual machines. None of it is tied one-to-one to real hardware. It's all virtual. But you simulate all the network stuff in software just like you simulate all the computers in software. And so OpenFlow is the main protocol used for SDN. And this lets you use a central controller to control your switching. What's MoBo? Oh, MoBo, I think, is an abbreviation of someone's name. Mobo Lojai or something like that. That's all. All right. So let's try Bo. Okay. Let's try the last Kahoot for today. I think I'm glad I set an extra day for this because, like I thought, 3 of these sections is about enough. We're up to 4F. Done with 4E. And here's 4F. Good. Ah, good. I'm glad you're happy. This is Net Plus at high speed. I taught this stuff for years. All right. Thought this was too wide? I guess not. Oh, I see. Okay, it was. Anyway. Me? Oh, no. I didn't come to San Francisco till I was about 30, I think. Yeah. All right, let's go ahead. All right, what link goes at 45 megs? All right, that's a T3, that's good. All right, how about a storage protocol? Yeah, I agree, Dice. I find this stuff a little puzzling because I haven't really worked with it. So it's sort of meaningless terms to me, but after a while you get to memorize them pretty well. Yep, Fibre Channel over Ethernet. All right, what protocol is used by the energy sector? DNP3, that's good. All right, and what's the most well-known SDN protocol? That's it, open flow. All right. Okay, Landoff. Okay, and Joseph again. And Louis again. Good. All right. So I'll stop the recording.